Welcome back to Arts Learning. In this video, we'll be going over MVP charts, which entails M for mass in kilograms, V for velocity in meter per second, and P for momentum in Newton seconds. Okay, we'll learn how to find out M, V, and P using conservation of momentum as well as some other tactics. Okay, so let's first understand what this looks like. The key rule here is that momentum before is equal to momentum after, conservation of momentum, right? And then we make a table out of that. We have an object 1, object 2, right? This is a table for objects. This is for mass, this is for velocity, and this is for momentum, P. So total P before must equal total P after, okay? And that's where this comes from. M1 times V1 is M1 V1, okay? That's our P here. M2 times V2 is M2 V2. So M1 plus V1, right? So M1 times V1 plus M2 V2 should give you this. M1 plus M2 times V prime. V prime just denotes velocity after, okay? Which is after the collision, what's velocity? So after the collision, M1 plus M2, that's your total mass, right? But what's the system moving at? That's your velocity after. Okay, so now let's try it on a fish. A 5 kg fish swims right at 1 meter per second, okay? So this is 5 kgs. And swallows a 2 kg fish swimming left 2 kgs at 2 meter per second. So how would I find the momentum afterwards of both these fish? So the big fish has a mass of 5, a velocity of 1, and a P of 5, okay, which is momentum. 5 times 1, 5 Newton seconds. Small fish, 2 kilograms of mass, 2 meter per second velocity, but this is going in which direction? The opposite direction, right? So it would be -4. You see, this was a trap. That's why these numbers are red here. This was not, this wasn't the real velocity here. It's -2, so it gives you -4. It's the wrong chart. So it was just to trick you guys, okay? So total mass would come out to be 7. Velocity, we don't know that yet. But what's our total momentum going to be? We started with this initial momentum, 5 minus 4, is equal to 1. So our total momentum afterwards must also be 1, considering rightward, the positive direction, okay? So then what's the velocity here? If 7, which is a mass, times velocity has to be equal to 1 for the momentum. It's 1/7, right? So 1/7. And there you go. That's how you use momentum charts. You add the masses here, you add the momentum, and then you can use that to figure out the velocity. Or sometimes you might be given the velocity and you can use that to figure out the other two. Okay, so like this, you see? Alright, so let's try building some MVP charts. A 3 kg cart, so let me just write it for the 3 kg cart here. At 4 meter per second, right, collides and sticks to a 1 kg cart at rest. Build the MVP chart. Okay, so what's our mass for the 3 kg cart? That's 3 kgs. It's going 4 meter per second to the right. Right, 4 meter per second to the right, and we'll say right is positive, so plus 4 meter per second, which means this cart's momentum is 12 Newton seconds. Here, it's the 1 kg cart. So 1 kg is the mass, and it's at rest, right? So it's 0 meter per second. And the momentum of something with 0 velocity is just 0 Newton seconds. So the entire momentum of the system is coming from the 3 kg cart. Afterward, what would the results look like? 3 plus 1, 4 kgs here, right? And then this we don't know. We don't know the final velocity, but we know that the final momentum has to be the sums of these, which is 12. So that means 4 kgs times what is equal to 12? 3 meter per second. That's our answer. Okay, so let's look at another one. And as always, right, the more harder problems will be on the PDFs on my website, oscillating.com, as well as the videos that I'll be going over the ones I deem hardest. So a 2 kg ball here is going at 5 meter per second to the right. So 2 kg, 5 meter per second to the right. I'll deem rightward the positive direction. Okay? And its momentum should be 10 Newton seconds. Kg times meter per second, Newton seconds. The other object is a 2 kg ball, another 2 kg ball. 2 kg ball number 2, because there's 2 of them, right? Mass would be 2 kgs. But this is going at left, so negative 5 meter per second. It's going in the opposite direction. And then this one's momentum would be negative 10 Newton seconds. So the total mass would be 4 kgs. Total momentum, so what's momentum initial? That's the sum of these two momentum, which is momenta, which is 0 Newton seconds. So then over here, this should also be 0 Newton seconds. And this should be, well, this we can't just figure out, right, from just that. We can't add these together. That's not how velocity works. We have to look here. What do we need to multiply 4 by to get to 0? Just 0 meter per second, right? Yeah, that's it. And the more harder problems, like I said, would just be on my website as well as the PDFs on my website. So now let's go over a preview of what we're going to learn in the next video. We're going to learn about collisions, okay? The 2 different type of collisions. So make sure to stay tuned and check that out. That video will be going over elastic and inelastic collisions and how to calculate both, as well as situations for perfectly inelastic collisions, okay? And what they mean. How does kinetic energy relate there? And all those good stuff. So make sure to stay tuned and give me a like and subscribe so I can help you as well as others more like you, okay?